Welcome to a new test and teardown video. This time it's a Holladay HI-3002 BroadBand RF exposure meter or survey meter for electrical fields. I got the suitcase with the H&E probe. That'll be the red and the green probe there. And I got I think this is an amplifier, peak, hold, different ranges and all that kind of stuff. It's actually really heavy. And then I also got a battery charger, and there's a screw missing, and it feels, yeah, see, also a oops. Yeah, this looks like somebody's been inside here and poking around with that one. So that is definitely a thing I need to open and investigate. That will be the probe holder handle. And I guess that cable goes directly into this amplifier unit, right? See the top of the handle. Oops, what happened here? Now the connector is all the way down there. That is not good. It used to be all the way up. Oh no, how did that happen? I need to figure that out because I looked at this yesterday and then the connector was all the way up there. Because if I take one of them probes, no, this is not a Maranka. You know, we could make some music, no, but this is not the case. So that will be, see, this is the voltage probe. Says something about calibration and stuff like that, right? Oh yeah. It's very, very lightweight glass fiber stuff. And here is this is the multi-connector. And let's look at the other. Oh, sorry about that. My other little Maranka here. So this is the current probe, as you can see here. And well, there's probably also some calibration factors and stuff like that. More or less the same connector. It's a little bit damaged, but I think that will do quite fine. There's a really, really funny thing I did not expect. Oh, it hasn't been opened. What? Look at that. A stethoscope type of hearing apparatus where you stick this. Maybe this goes into that connector. So maybe there's a speaker in here. So maybe we got some beepity beep sounds or some stuff here. Recorder output, and that will be the... Oi. Look at that. We got a battery in here. Blinking, normal, steady, low. All right, so we got a low battery in this unit. I was a little bit through eBay, and I found two of these on eBay. One is $116 just for this unit. And probably my unit here is in a very nice state, at least looking like it is quite nice. We got some calibration and stuff. See, this is from 2001. All right. And I also found another one on eBay, $100. And that was this whole suitcase with everything, but it was super nasty and slimy. And that is a classic problem with this foam here. It kind of dissolves. Oh, mine is quite alright still. But I don't know if it's moisture or exposure to air or sunlight or whatever it is, but this kind of foam completely dissolves and turns itself into nasty slime with time. That is just a problem. So open the top here. Oi. That is some hefty battery pack. What a surprise. So that will be the battery charge connector down there. This looks like it's one of these connectors that's kind of short. When you plug them, maybe there's a diode or something here, right? They are all in series, maybe? That is a lot of volts. Amazing. And then how do we open? Aha. Hang on, I need to disconnect this. So now I'm inside. When I pull this out, these little plastic holders kind of fell out. And look, it's not exactly the same distance. So here it's shorter and here it's a little bit longer. So this is something I need to pay attention to. But definitely we've got these little plastic things. And I bet that is to hold the three boards here in place. And they are just, I think you just stick them on. And then, yeah, here, right? Oh, this one first. And they just, hold this piece of aluminium here just holds these in. That is funny. It is absolutely amazing, this design. What do you know? So that will be the sensor inputs. We've got quite a lot of wires to the sensors, and that is a little bit interesting. What exactly are they doing? And the way that the wires are twisted. So we got some twisted pairs of detection. Also some capacitors. And then some trimmer resistors, capacitors, probably some gain. All right. What is that? Analog switches or something like that, right? Or gain stages. I will have to look these up. I think I figured this out a little bit better. So all those input capacitors and all that stuff here, that acts like an input filter because it has to be DC voltages. So I think the detect diodes and stuff like that is rectified up in the antenna heads. So the DC voltages, they come in here, right? We've got 4 pair of wires, so they are common mode filtered and handled really nice like that. And because of modulation and stuff like that, we got some capacitors here to speed up that kind of stuff. And then we got 4 op amps right here. And those 4 op amps, they are the LH-0022CH single field effect transistor high precision op amps. And then the 4 pair of signals goes to the analog switches. So if we see those 2 analog switches, this one is the IH-6108. So this is a 8-to-1 analog multiplexer. And the other one, the 6208, that is a dual 4-to-1 analog multiplexer, analog switch, right? So that means the electronics will switch the different signals around and then measure these 2 in pairs and something like that, right? We got some more op amps here. This one is an 8582KH sample hold chip. And that will be the digital interface for everything here that's going on. The This one, the ZN432E, that is a 10-bit sample. No, this is a AD converter. So that's a 10-bit AD converter. Really nice. It's a successive approximation analog to digital converter. And it is a little bit funny with those SAR converters. The way that they work is that you actually have a digital to analog converter, and then you compare with some op amps when you have the right input that matches what you are generating, then you have made the correct analog conversion. So the output from the AD converter goes to this EEPROM. Maybe I should try and take off the top board. I was hoping we could do that. Quite nice with those interconnects, double-sided circuit board. It looks like the layout is done manually. Look at the way the tracks are made, and not not the straight lines and all that kind of stuff here. This is typical manual work. You would not see lines like this if it would have been done on a computer program. So the next board here. So of course I think the EEPROM takes the data, because that will be address lines that goes to the data output from the converter. They go down here. And then you have a lookup or conversion, linearization, all that kind of stuff is done in this one. Isn't that a nice way to do it? And quite a lot of TTL circuits. Yeah, some counters and all that kind of stuff. That's quite funny. All those, that would be 10-bit counters. I was looking for a digital to analog converter to drive the meter is mounted here. So I don't know if I can get this out. There's probably a digital to analog converter somewhere. Where is the data going from the EEPROM? Down here we have the data outputs from the EEPROM. So where is that going? Is that going to this one? This is not a DA. So I don't know where the DA is right now. Got some... I don't know. Maybe this is done in a little special way. Probably it's counting around. You can actually make a digital to analog converter by PVM and like rippling around and all that kind of stuff. You can make a lot of cool things because you have a lot of memory in these. So let me see if I can take this board away as well. It's amazing, this circuit board. Look at those ultra thin tracks. It's like they're almost trying to have as little copper left on the circuit boards as possible. Today I do exactly the opposite. I try to leave as much copper on the circuit boards as absolutely possible, both for tracks and for grounding and everything like that. So it's a completely different way of making a circuit board. That's a little bit interesting. So that will be the last of the circuit boards. So I don't know if I am able to get that one out because it's soldered to, oh no, yeah, we got switches here and all that kind of stuff, and then we got all those ICs. No, I don't think I want to take this out. I really don't want to ruin it, because it's actually a really nice instrument and I really hope it works. Everything here is quite nice, nicely made. So I think I want to put it back together. It looks like somebody did desolder the 2 wires here for the B and C connector for the recorder. And yeah, see, it was definitely a beeper connected. Like the audio from the beeper goes here, so you can have these headphones kind of style on. I think maybe if you're using this instrument in an area where we have humongous a lot of noise, this the headphone here to tell you when you have overload, and then you will turn off your transmitters or make more distance, right? Yeah, but I think we have seen enough. I think I want to try and put this together again, and let's see if we can make it work. I'm playing a little bit around with the charger, and it seems like the only thing that gets really warm is this diode here, so I don't know exactly what is going on. I think I want to measure that diode is okay before I proceed anything. There's not a lot of weight to this power supply battery charger here. We've got a charging LED power on, and yeah, the fuse is okay, and I mean, this is all there is to it. Some high precision resistors, right? Yeah. So I guess this one is not going to charge really fast. I think I should just try and power this up and measure if we got voltage out of that. I really don't like this way of charging, because when you plug these in and out, you're gonna create a short. So it's probably written in the manual, you stick this in and then you power it on, right? So let's try and power up the charger. Okay, 23 volts. That's interesting. It's using 3.9 watts. And yeah, the on LED is definitely on. I really feel lucky. Let's try and connect this to the battery. Aha, good. I think that is a good idea. And then I will try and plug this in. The big fat battery, just do it real fast. And remove everything. Ooh, and the charge LED is on. Nice. Maybe I should measure. Oh, let's turn it off immediately. What I want to do is measure the voltage out of the battery pack. We got this wire here. Maybe we could measure if the voltage goes slowly up. Or is this disconnected while we are charging? Yeah, you see, we got no. Aha, that is how it works. See, we got 0 voltage out here, and if I disconnect the charger, then we have, oi, that is not a lot of voltage. Only 8.3 volts. And all those cells, 14 cells, but I don't know if they're in series or in parallel. Well, I think I'll just plug this back in. Let the charger do its thing, and then I'll come back in an hour and see what happens. Running only 10 minutes or something like that. What I can do is I can measure the charge voltage here if I'm really careful. Oi. And if I just hold it here for a second, see, voltage is climbing, and all that is perfectly fine. That is what we want to see. I think this is an overnight charger, so I'm probably just going to leave it for a long time and see what happens. Nothing gets warm. No, not even this diode. No. Not a problem on anything here, so I can just leave it and be happy. So this was absolutely fantastic. After a whole night, I got now 19.5 volt on all those cells, so that means they're in series. And you know what? Look at that. It's now blinking like that quite fast. So blinking means it's normal. So we got nominal voltages. And I will put back everything and let's see if it works. So let's see what happens. Here's the most sensitive range. I don't know if this is really visible, but can you see I'm now in the most sensitive range? Okay. And here's the voltage probe. Here's a little VHF transmitter, and this is capable of doing quite a lot of watts. So if I take it all the way out here, see? Can you hear the clicks? This distance go over range, right? See? And if I crank up the level, this is a factor of 10. And then again, let's take another factor of 10. And here we go. Now you can hear the clickety click. And see? This antenna here, oops, should have a absolutely round sensitivity, because this is called an isotopic antenna, and this is a voltage probe. I actually think we got more than one probe in here, and they're coupled together inside this unit, and it's measuring the differences and all that kind of stuff. So it's going to be as round as possible in its radiation pattern. And so that means it doesn't matter how you hold this probe in this angle or that angle or whatever, right, towards the objects you want to measure the level. And this way you can prove if there is any radiations over a certified limit. And all that comes back to the way this antenna is calibrated. And yeah, this should be back in 2001, when this was, of course, calibrated. It was used for certification of radiation of different products. So that is quite amazing. I think I can really use this as it is for EMC testing and all that kind of stuff. So definitely, I think this is going to be a keeper. I really wanted to know what was inside those marangas here, but I'm afraid that I can't open these without destroying them. So I think we're not going to have a look inside these. I think it is a little bit too dumb to destroy them, just to show you the pickup antennas in here. I mean, that's just how it has to be sometimes. I'm sorry, because I don't want to destroy very, very super good, nice and useful instruments like this. I can use this in my daily work, really. So that is what I wanted to show you in this video. Thank you very much for watching.